Our next problem may look different because it has more variables, but it's going to be the same steps as the other problems. The first step is to factor the denominators. Now we can't factor x plus 3, we can't factor x minus 3, but we can factor x squared minus 9. That's a difference of squares. And you might remember from factoring those, the square root of x squared is x, the square root of 9 is 3, and you put a plus in one group and a minus in the other group. So you can see that the common denominator that includes all of our possible factors here is x plus 3 times x minus 3. So let's take the time to write that out so that we won't make as many mental mistakes. X plus 3, x minus 3 times 2 over x plus 3 plus x plus 3, x minus 3 times 3 over x minus 3 equals x plus 3, x minus 3 times 2 over x plus 3, x minus 3. It does take time to write out that step, but I think you'll make far fewer mistakes if you do write it all out instead of trying to do it all in your head. So on that first term, the x plus 3's cancel out, and we have x minus 3 times 2. X times 2 is 2x, minus 3 times 2 is minus 6. On the next term, the x minus 3's cancel out. X times 3 is 3x, 3 times 3 is a positive 9. And on the right side, x plus 3 and x plus 3 cancel out, x minus 3 and x minus 3 cancel out, and we're left with 2. So here I think you can really see why we do this getting rid of the fractions. For most people, this equation is so much easier to work with than the one that has the fractions up there. So now we combine the like terms and we would have 5x plus 3 equals 2. Subtract 3 from both sides, and we have 5x equals negative 1. Divide both sides by 5, and we would have x equals negative 1/5, like so. All right. Oh, hold on. I just realized I made a mistake. But hey, it's good I caught it now. That's a negative 2. So this should be a negative 2, which means this is a negative 2, this is a negative 2. I got my answer wrong, but that's okay. This would be a negative 5, and we should end up with negative 1 for the answer. Sorry about that mistake. I'm sorry if it was confusing watching that part. Okay. Let's take a look at our next example. Here we have 5x over x minus 1 equals 5 over x minus 1 plus 3. So here there's nothing we can do to factor the denominators, and our only denominator here is x minus 1. So let's multiply that denominator by every term. X minus 1 times 5x over x minus 1 equals x minus 1 times 5 over x minus 1 plus x minus 1 times 3. So looking at this, on the first part, x minus 1 and x minus 1 cancel out, so we have 5x. On the next part, x minus 1 and x minus 1 cancel out, and we just have 5. And then that last part, there's nothing to cancel out, so we distribute. X times 3 is 3x. Negative 1 times 3 is minus 3. So we combine like terms on the right side, and we would have 5x equals 2 plus 3x. Then we subtract 3x from both sides, and we have 2x equals 2. Divide both sides by 2, and we get x equals 1. Now think back to the fourth step of solving these equations that we had on the first page of the notes, which said, check your solutions to make sure that the denominators of the original problem would not be 0. We haven't had to worry about that yet, but if you take a look at this problem, we got x equals 1. And if we go back and check that in the original problem, we would end up with 1 minus 1, which gives us 0 on the bottom of the fraction. And we can't have that. What that means is that x equals 1 is a false answer. Sometimes in math, this is what's called an extraneous solution, a solution that you get by following the correct algebra steps that is not actually a solution to the original problem. So x equals 1 is a false answer. What I like to do is put a big X through that, just to remind myself that it's not actually an answer for this problem. And since we don't have an answer that's correct for this equation, here we can say that there's no solution to this problem. Let's try our next one. Here we have x minus 6 over x plus 3 equals 2x over x plus 3 plus 2. So here, our denominator is x plus 3, and we can't factor it, and that's our only denominator. So like our last problem, we're going to multiply that by every term. X plus 3 times x minus x plus 3 times 6 over x plus 3 equals x plus 3 times 2x over x plus 3 plus x plus 3 times 2. We multiply every term in the problem, whether it's a fraction or not, by that common denominator. So now in the first term, there's nothing to cancel out. X times x is x squared. 3 times x is plus 3x. On the next term, the x minus 3 and x plus 3 and x plus 3 cancel out, and we've got a 6 on top of the fraction. But here's a mistake a lot of people forget, that there's a minus in front there. That minus hasn't gotten canceled out. So instead of a positive 6, here we have a minus 6. Now on the right side, x plus 3 and x plus 3 cancel out, and we're left with 2x. The next part, nothing cancels out, so we distribute. X times 2 is 2x. 3 times 2 is 6. So if we combine the like terms on the right side, we have x squared plus 3x minus 6 equals 4x plus 6. Now we need to keep going. We need to get everything on one side so it's equal to 0 and we can factor it. So we subtract 4x from both sides and we subtract 6 from both sides. Doing that leaves us with x squared minus x minus 12 equals 0. And now to finish the problem, we factor it. Here you've got to be careful with the signs especially. To multiply to be a negative 12 but add up to a negative 1, you would need a minus 4 and a plus 3. And now that we're done with the factoring, we set each one of those equal to 0. X minus 4 equals 0. X plus 3 equals 0. The first one, you add 4 to both sides and have x equals 4. The next one, you subtract 3 from both sides and you have x equals negative 3, like so. So taking a look at that, we've done the algebra. The trick with this one is, as will often happen on some of these problems, you'll end up with one answer that's true and one that's false. We check those by looking at the bottoms of the fractions from the original denominator, or from the original problem. For 4, if you put in 4 for x, you get 7 on the bottom of the fraction. And that's fine. You can have 7 on the bottom of the fraction, so that answer is okay. If we put in negative 3 for x into the bottom of the fraction, we would have negative 3 plus 3. We get 0 on the bottom of the fraction, and that makes negative 3 a false answer. So I would circle the 4, but put an x through the negative 3. That answer is false. Let's take a look at one more example for this section. Here we have 1 over x plus 2 equals 4 over x squared minus 4 minus 1 over x minus 2. So first step, factor the denominators. We can't factor x plus 2, so we leave that alone. For x squared minus 4, we can factor that one. That's going to be x plus 2 times x minus 2. That's the difference of squares. The last one we also can't factor. All right. So now we can see that the common denominator we need to multiply by to get rid of the fractions is x plus 2 times x minus 2. So we're going to multiply that by every term. X plus 2, x minus 2 times 1 over x plus 2 equals x plus 2, x minus 2 times 4 over x plus 2, x minus 2, minus x plus 2, x minus 2 times 1 over x minus 2. Like that. So now we look for things to cancel out. On the first part, x plus 2 and x plus 2 cancel out. X minus 2 times 1 is x minus 2. On the next part, x plus 2 and x plus 2 cancel out. X minus 2 and x minus 2 cancel out. So for that part, we just have 4. The next part, we have x minus 2 and x minus 2. Here you've got to be really careful with the negative signs. What we've got is a negative times x minus 2 times 1. So if we do negative times x minus 2, remember that's like having a negative 1 times x minus 2. If you distribute that negative 1, we would have a negative x and a minus 2. So we've got to be really careful about that here. Okay. So now we combine the like terms on the right side, and we have x minus 2 equals 2 minus x. From here, there's a bunch of things you could do next. What I would do is move all the variables to the left side by adding x to both sides, and then move all the numbers to the right side by adding 2 to both sides. And when we do that, we end up with 2x equals 4. Divide both sides by 2, and we end up with x equals 2. But that's actually not a solution to this problem. Again, if you check the bottoms of the original fractions, this one would take that last fraction and make it 2 minus 2, which is 0 on the bottom of the fraction. And that's going to make a false answer because you can't have 0 on the bottom of the fraction. So here, the only answer that we got with algebra was a false answer. So for this problem, we would need to put no solution.